Okay, now we're going to look at prime numbers. So let's have a look at these numbers here. So I've listed numbers 1 to 15 on the left there, and then their factors on the right. So if I'm looking at these, I'm going to get you to look carefully. We're going to look at numbers 1 to 10 right now. So just right to here. And we're going to look carefully. And I'm going to tell you right now that by looking at those, 2 is a prime number. 3 is. 5, 7 are also. Okay, and then if I'm looking at these again, I'm going to look at composite numbers. So I'm going to tell you that 4, 6, 8, 9, and 10 are what are called composite numbers. So 4, 6, 8, 9, and 10 are composite numbers. Okay, and then 1 is not either. It's not a composite number or a prime number. Now, if you look at the red and ignore the 1, what do they have in common? So I'm hoping you notice that they only have 2 factors. And what do the blue ones have in common? They have more than 2 factors. All right, so I'm wanting to know if, based on what we just discovered and just talked about, let's look at 11. Is 11 a prime number then, or a composite number? So 11 would be a prime number. What about, is 12 prime? No, 12 would be a composite number. 13? Yes. 14? No, it would be a composite, and so would 15. So looking at what we just did, what numbers were prime? The numbers that were prime only had 2 factors. And what numbers are composite? They're any number that has more than 2 factors. And 1 is neither. 1 is a factor of all numbers, and 1 is neither prime nor composite because it has exactly 1 factor. Okay? All right. So what I want you guys to do right now is work through these 4 problems and tell me if they are prime or not. So pause the video. Okay, so I've already done them. Obviously, this one is prime, but which one was the most difficult for you to check? So that should also be 29. And oftentimes what people do is they check all the way up to 28, from 1 to 28. And do you really think you need to check all of those numbers from 1 to 28? So I'm going to look for a pattern that's going to help eliminate those possible numbers as factors. So we're going to look at 30 instead of 29 first. Okay, so these are the factors of 30. And I'm just going to put them in their pairs. So 1 times 30, 2 times 15, 3 times 30, and 5 times 6. Okay, so that's my list. So what is the smallest factor of 30 that's greater than 1? So that would be 2, right? Notice that, or what is the largest factor of 30 less than 30? And that is going to be 15, right? Oops. So notice that these multiply to give you 30. This is because if there was a larger factor of 30, it would have to multiply with something less than 2 to give 30. It would have to fit on the number line in between 1 and 2. And factors can only be whole numbers. They can't be 1.5. Okay, that can't be a factor. So there's no way that there's a number greater than 13 or 15 that's going to be a factor. So I'm just going to have you now predict the largest factors for here. Pause the video again. Okay, so the first thing that I do when I'm going to predict the largest factor, I'm going to divide this by 2, and I know that the largest factor is going to be 10. So this one is going to be 21. This one is going to be 18. And this one's going to be 20. Super easy, right? So those are going to be the largest factors. Now, what is the smallest factor of 45 other than 1? And I try to divide by 2 and that doesn't work. And divide by 3. So 45 divided by 3, and that's going to give me 15. Okay, so the largest factor is going to be 15. And I know that because I can't divide by 2 without getting a decimal. So in order for there to be a factor that's larger than 15, the number that I'm dividing by would have to be in here somewhere because it needs to have that pair. So that's not going to work because it needs to be a whole number, right? All right. So I just want you to figure out the largest possible factors here. And pause the video. Okay. So 15, I can't divide by 2, but I can divide by 3, and that's going to be 5. So the largest possible factor is 5. Okay, so I'm going to divide here by 2. And that equals 8. So that's going to be the largest possible factor. I am unable to divide by 2, 3, 4, 5, 6, 7, and 7. Oops, 7 I can. So this is going to be 7, and that's the largest possible factor. And here, I know it's 75, so 2 doesn't work because it's not an even number, but 3 will. So the largest possible factor here is 25. Okay, and I know these are wrong, but that's fine. Okay, so now let's have a look back at our original factor of 20, or like finding the factors of 29 and whether or not we really need to check all the numbers up to 28. So using what we just learned from the factors of 30, so we're going to look at the smallest possible factor and predict the largest possible factor. So I have 29, and the first thing I'm going to check is 2. So I know that 2 times 14 equals 28. Okay, if a number more than 14 was going to be a factor, I would have to multiply it by a number that's smaller than 2. So that's not going to work. Okay, and if I multiplied 2 by 15, that's going to give me 30, and it's already too big. Okay, so I know that 2 is not going to be a factor. So we've gotten rid of half of our workload because we know the number is going to be somewhere in between here, if there is a number. So then I move on to 3, and I know that 3 times 10 equals 30. So it would I'm going to try then 3 times 9, and then that is going to be 27, so that that's not going to work as well. Then I'm going to try 4 And 4 times 7 equals 28. So that's not going to work. So I know I'm going to keep lessening this gap between these numbers. So I can only try numbers 5, 6, and 7 now. So 5, I know times 6 equals 30, so that one doesn't work. And now these numbers are beside each other on the number line. And so I know I don't have any other numbers to check. So I don't need to check all the way up to 28. I can stop right here, and I know that this is a prime number.